Welcome back to this class. Let's consider classification of elements. First, elements can be classified in several ways, but here in this video, I am going to take just two ways to classify elements. So the first way I'm going to classify elements is based on natural radioactivity, and secondly, based on properties. Now, based on natural radioactivities, elements can be classified into two. We have the radioactive elements and the non-radioactive elements. So now, based on properties, elements can be classified into three. We have metals, non-metals, and metalloids. So now let us break each one of them down one after the other, starting with the radioactive element. Now let's consider radioactive elements. Radioactive elements are those elements that undergo spontaneous decay or degradation, followed by the emission of one or more of the radiations, alpha particles, beta particles, or gamma ray. So the definition is as simple as that. So in this definition, we will understand that there are certain elements that can split on their own. Normally, elements do not just split because according to the definition of elements, we said elements are substances that cannot be easily split into simpler units by an ordinary chemical means. You can see that the definition of an element is very clear. Now, what happened that some other elements can now split? So that indicates that there are some exceptions to the rule. And these exceptions are the radioactive elements, because the natural rule for elements is that they cannot be easily split. But this time around, these other categories of elements can split on their own, which contradicts the initial rule that we have in the definition of elements. So it means that those radioactive elements, they take an exception. So now, the radioactive elements can split on their own after a particular period of time known as their half-life. When one half-life completes, they split naturally into two substances. And during this splitting, or after this splitting, they are going to emit some radiations. This can be alpha particle, or beta particle, or gamma ray. You will learn more about this when you get to higher chemistry, like SS3 chemistry. When you get to higher classes like SS3, you learn more about radioactive elements. Now, let's consider examples of radioactive elements. Examples are radium, Ra, uranium, U, francium, Fr, polonium, Po, thorium, Th. So let us consider the periodic table and see where we can find the radioactive elements. Or before that, the reason why radioactive elements can easily split, that they can split into two, or they can undergo spontaneous disintegration. This is because they don't have stable nucleus. They have an unstable nucleus. But other elements that cannot perform this, they have stable nucleus. So the entire splitting process of radioactive elements is termed nuclear reaction. That is a reaction that takes place in the nucleus. Now consider this periodic table. This periodic table is very colorful. So the color indicates, they use color to indicate the radioactive elements. So any box that is colored with this color is radioactive element. So the first one here is the element with the atomic number 43, which is technetium. So that's the first radioactive element that we have here. And that is found among the transition elements, which is in block D. This is block D. Technetium is found here. So it's a radioactive element. But majorly, radioactive elements occupy the actinide series. Look at this element that we have here. All of the elements that we have in this series, this last row of the periodic table is known as the actinide series. All of them are radioactive elements. So from the atomic number 93 up to 103 are specially called artificial elements because they don't occur naturally. They are produced in the laboratory artificially. Now, this upper column that we have here is known as the lactinide series. It is only one of them that is a radioactive element. So PM with the atomic number 61, which is known as promethium. That's the only radioactive element that we have among the lanthanide series. Now, check this row also. You can see that the entire row are all radioactive elements, which is row 7, that is period 7, starting with francium, radium, and so on. They are all radioactive elements. And if you consider period 6, where we have polonium, astatine, and radon, these three are also radioactive elements. So thank God for the color. This color makes us understand and identify the radioactive element. So that is how we can study about radioactive elements. We'll study more about it in subsequent videos. So radioactive elements, they don't have stable nucleus, and that is why it is easy for them to split. But other elements are called non-radioactive elements. All of these elements whose color are different from the one that we mentioned are known as non-radioactive elements. Why? Because they have stable nucleus. All of these usual elements, all of the first 20 elements, none of them is a radioactive element. From number 1 to atomic number 20, which is hydrogen, down to calcium. So they are not radioactive elements, and many more are not radioactive elements. So then it means we can define non-radioactive elements as those elements that cannot undergo spontaneous disintegration. Why? Because they have stable nucleus. And the example of where we can find them in the periodic table is displayed above. Let's consider the periodic table one more time. So check the periodic table. All the other elements, apart from the one with this color, are non-radioactive elements, starting with hydrogen down to bismuth with the atomic number 83. They are all non-radioactive elements, with the exclusion of technetium, Tc, with the atomic number 43. So because that is a radioactive element.